Hello all participants and all panels. So today I'm going to present about complementary split ring resonator or CSSR as a viscometer for engine oil. And by the way, my name is Andy Anapuja. I'm from Polytechnic Kuching, Sarawak. This is my team of researchers from Polytechnic Kuching, Sarawak and University Tun Hussein Ong. So Dr. Ong, me myself, Andy, and Alexander are from Polytechnic Kuching, Sarawak. Dr. Ski, Dr. Sia, and Dr. Pauline Ong from University Tun Hussein Ong. This is the presentation content. So I'll present about background of the study, objective of the research, methodology, result, and conclusion. Let's start with background of study. So in this research, we will study engine oil. So engine oil is used to lubricate moving parts of engine, reducing friction, protecting against wear, removing contamination for engine, and act as a cleaning agent, and act as an anti-corrosion and cooling agent. And then used lubrication oil are byproduct used in vehicle and machinery. They must be replaced on regular basis in our operation equipment due to the contamination from dirt, water, salt, metal, incomplete product, and others. So our purpose of study actually is to find out the characteristic of the engine oil. In this study, we will study about the viscosity of engine oil. So what is viscosity? It's a measure of fluid's propensity to flow. There are two kinds of viscosity commonly reported: kinematic and dynamic. Dynamic viscosity is the relationship between shear stress and the shear rate in the fluid. Kinematic viscosity defined as the ratio of viscosity to the density of fluid. Viscosimeter is an instrument used to identify the resistance of fluid to shear or tensile test. It is found on current standard laboratory viscosimeter for liquid such as U-bend, falling sphere, falling piston, or falling ball, and so on, require cumbersome operating procedure and time consuming. So we are trying to come up with a new method. Fluid manufacturers can improve viscosity index of base oil by using polymer additive to form multi-grade viscosity oil. These modifiers are temperature sensitive. So in this research, we use a lot of type of engine oil. This figure shows two types of engine oil, multi-grade and monograde. Here I will explain about engine oil code. So for multi-grade, we will see W, that means winter. And then for the monograde, SAE stands for Society of Engineers. And this viscosity value are taken at 100 Celsius. Definition of dielectric measurement. Dielectric insulator that does not contact current such as plastic, wood, polymer, and pure water. Response of dielectric material when it is exposed to electric field and polarization. The parameters that can obtain from the dielectric measurement are dielectric constant, loss factor, and relative permeability. Figure below show few examples of materials and their dielectric constant. So we have alumina at 9.0 dielectric constant, egg white at 35 dielectric constant. In this research, we use dielectric measurement open-end corrosion line type. This is the setup we do it in UTHM. So we have network analyzer, computer, and open-end corrosion probe. This is the type of network analyzer that is used in Polytechnic and UTHM. And resonators are attached to this network analyzer. Let's go to the objectives of this research. First, to set up dielectric measurement system which can accommodate inedible oil samples with different viscosity, this engine oil. Number two, to investigate and to characterize the relationship between viscosity and dielectric properties of monograde and multigrade engine oil using complementary split ring resonator (CSSR). Methodology. The fabrication process of the resonator. The milling process was performed to cut the printed circuit board PCB into the desired size and shape. CNC using a 3D printer concept was used, and various PCB milling bits were tested to produce the fine and smooth cutting edge for the PCB. Next, the etching process was performed to form the design of the PCB, and we are using the direct toner transfer method. This figure shows antenna or probe design. Patch antenna was one of microstrip design of microstrip structure. The patch antenna consists of a design top layer, FR4, and a ground. We are using Grabber software. This figure shows our fabrication of different types of antenna probe with square double slit ring resonator. Resonator is a device that can detect the resonance based on frequency shifting. It's printed on antenna probe, and then this antenna is attached to network analyzer to get the dielectric of material. This figure shows our final design, complementary split ring resonator (CSRR). Network analyzer was connected through SMA connector through a high precision cable to carry on this research. This is the setup of our experiment. Before the start of the experiment, slot tape was attached to the resonator, was replaced after its testing to eliminate the washing process. The experimental setup for this attempt is shown in the figure below. A 3D printed cubicle as a casing was placed at the sensing part of the resonator to avoid oil leak from the sensing area. Then, 5 drops of oil are dropped into the 3D printed cubicle using a pipette to obtain relative consistent volume in each sample, and the cubicle was placed at the center of the location of the ring. The testing started only after a minute to allow any bubbles to form during the dropping, disperse, and for the oil to settle evenly. For our experiment, we only use shell engine oils. As for the viscosity, the data were extracted from the technical data sheet from Shell official website. Engine oil was tested and repeated 3 times before the mean value was determined along with a frequency of 1 to 8 GHz. This figure shows few types of engine oil and their kinematic viscosity at different temperature. As for the result gain are shown in figure A and B. The focus points were in the range of the frequency earlier that exhibit possible relationship between viscosity and dielectric properties. S11 at the range of 1.15 to 1.17 GHz and 5.57 to 5.63 GHz. However, the result gain are disappointing as weak or no consolidated relationship can be seen between 2 variables measured. Even though there is marginal difference in their dielectric properties, it is still impossible to segregate them based on their correlation with viscosity properties. This is the figure mentioned before. So in these 2 range, 1.15 to 1.17 and 5.57 to 5.63, S11 shows the most significant possible result. As for the conclusion, in this work, a viscometer operated based on dielectric spectroscopy is proposed. Antenna with CSRR as dielectric sensor was designed, fabricated and tested with different engine oil with different viscosity. However, the results show no convincing and solid correlation between 2 variables, maybe due to small dielectric constant variation of engine oil with different viscosity. As for the recommendation, future work will be applied to current resonator to other applications associated with different material properties in order to build a predictive model. With this innovation, data documentation will be systematic and the measurement will be complete in a shorter duration without involving complicated operating procedure. The robustness of this system will enable in situ measurement. That's all from our group. Thank you for listening.